College Algebra 5.8 partial fractions. This will be the A video of this lesson. The lesson isn't too terribly long, but sometimes when I teach this lesson, it just takes me a little bit of time to get it down to you. So first of all, what is a partial fraction? All right, so sometimes in calculus, it's useful to be able to take a rational expression, like this here, and write it in two or more simpler expressions. Okay, so this here equals this. If we were to find common denominators and add our numerators up, we would get this as an answer. So what we're going to learn how to do is, you already learned a long time ago how to take this, find common denominators, add them, and get this. Now what we're going to do is we're going to take this and turn it into these two simpler expressions here. So this right side is called a partial fraction, and it's also called a well, each one of these is called a partial fraction. The whole thing is called a partial fraction decomposition. So we're going to learn how to go from here to here, what it was that we added together or subtracted in order to get this answer right here. So these are not factors of this because they're added. Factors are multiplied to give us this side. Since they're added, they're not factors. They're called partial fractions. So my difficulty in teaching you the decomposition of partial fractions is how much theory to go into. How much do I explain not only how to do this, but why it works. So I kind of take a middle of the road approach and give you little bits and pieces. But key thing that's important is the degree of the numerator has to be less than the degree of the denominator. So this has a degree of 1, this has a degree of 2, so the numerator is less than the denominator, so we do it. If the numerator has a degree higher than the denominator, we have to do some other work here in order to do that. So we'll do both of those ways in order to make that happen. And just kind of teach you, I think there's 3 different situations that we run into. One is when the numerator is lower. I'm just going to use this here. The numerator is less than the denominator as far as its degree. When the denominator is less than the numerator, or if, gosh, I don't even know how to explain this, if one of the factors is of a higher power. So if we have like 2x minus 1, and this is our denominator, let's say, and this second factor here is squared. There's a certain method in order to solve if that's the case. So those are the 3 things we're going to look at. When the numerator is less than the denominator, when the denominator is less than the numerator, and how we change it so it's this way, and when we have one of our factors to a higher power than 1. How do we do that? So those are the 3 methods we're gonna look at. So let's go ahead and get started with our first example, and just gonna kind of talk you through it. Like I say, it'll probably take a few videos to get through it because of my talking, but I'll try to get it through to you as quickly and simply as possible, but you know me, I talk a lot. Alright, so there's our expression, and good news is the degree of the numerator is less than the degree of the denominator. So this is the one that I just had written on there before, and we're going to actually decompose this into partial fractions. Alright, so first of all, what we're going to do is we're going to take this and we're going to simplify it, which means when it's a quadratic, we're going to simplify it into linear factors. So, got that. Okay, so we just factored our denominator down. That's all we did. Not so hard. Now what we're going to do is we're going to write that as one of our factors here and one of our factors here. Okay, we're going to put a plus sign. What we don't know is what goes here and what goes here. So what we're going to do is we're going to call that an A and a B, because I know something's going to go up here. All right, so from what I have here, I am saying that this expression here equals the sum of these two expressions. So when I add these two together, I'm going to get this as my denominator and this is my numerator. But these are not multiplied. It's added, so it makes a little bit of a difference here. All right, so what do you do when you want to add these two expressions here? Well, you find a common denominator, right? And a long, long time ago, I taught you that if you have denominators that are weird like this, you look at this and say, what have I got? What am I missing here that I have over here? Well, I have an x plus 2, but I'm missing a 2x minus 3. So I'm going to multiply top and bottom by 2x minus 3. Now I look here and say, what do I have here, or what am I missing here? I'm missing an x plus 2. Okay? Now let's write what I have here. This here, what does that look like? Well, since my denominators are the same, I can put everything together, right? So there we go. It's just like writing 2/3 plus 1/3. That is 2 plus 1 over 3. That's the same thing I did right there. Okay, I just put my numerators together over that common denominator. And that equals my 4x minus 13 over that. Okay? So notice I didn't do anything with this left side, and I'm not going to. Okay, but notice what happened here. My denominators are the same. If my denominators are the same, then my numerators are the same. So all I care about now is my numerator. I know my denominators are the same. Okay. All right, so let's move everything up out of the way here, because I don't care about anything else now except what I have right here. Okay, that's all I care about. All right, now the next step, and this isn't hard, it's just the next step. I want to get rid of, well, let's say I want to get rid of the b, because if I get rid of the b, then I can find a, right? So what I'm going to do is I'm going to say, what if x plus 2, this right there, equals 0, x equals negative 2. So I'm going to plug negative 2 in here for any time I see x. And what happens when I put that negative 2 in here? Negative 2 plus 2 is 0 times b is 0. This whole thing will disappear, which leaves me with just a. So I'm just going to rewrite everything with negative 2. 4 times negative 2 minus 13 equals a. 2 times negative 2 minus 3 plus b. So that goes away. Negative 8 minus 13 equals a times negative 7. So negative 8 minus 13 is negative 21, equals negative 7a, divide by negative 7, divide by negative 7, a equals 3. Okay, so that's what I was looking for. Because if you remember, let me see if I can get some of my stuff down here that I need. I don't know if I can or not. Ah, there it is. There's my original problem. I wanted to find an a, because this plus this equals this. So I found a is 3. So I'm going to put a 3 up there. Now I'm going to find the b. So I'm going to move this over here now because I might need it later. See if I can get all this other junk out of here. And just give you what I need. Sorry about this. Frustrating that I can't erase all of this. Okay, so there's my problem back, my numerator. Okay, so I found that a is 3. Okay, so this part right here, I found that this was a 3. Now I want to find this, and then I'm done. So let's move that back out of the way. So remember, I took x plus 2 and made it equal to 0. Negative 2 plus 2 equals 0, so that when I multiplied it by b, it disappears. Now I want to make the a disappear, so I'm going to take this and set it equal to 0. And find out what x has to be in order for that to be 0. Three halves. So I'm going to multiply everything by 3 halves. So I'm going to turn this off while I write this. Okay, so see, all I did was replace my x with 3 halves because that makes this 0. Alright, so what do I have over here? I've got 12 over 2. 6 minus 13 equals a times 6 over 2 minus 3 plus b times 3 halves plus 2. Alright, so this goes away because that's 3 minus 3, so I don't have that to mess with. I have negative 7 here plus 3 halves b plus 2b. Common denominators, make that a 4 over 2, so I can add these. Negative 7 equals 7 halves b. Divide by 7 halves, invert and multiply, get negative 7 times 2 sevenths equals b. So b equals negative 2. Okay, so now I have a and I have b. Okay, so let's go back to this original problem here. And I have, what did I say a was? A was 3 minus, I have a b there, so our negative 2. So instead of the plus, I'm just going to say minus 2 over 2x minus 3. Now, if I were to take this and add it together, I would get this back. So I decomposed it. All right? That really is how everything that you're going to do in this lesson is done. We've got a little tweaks here and there, but mainly you're going to follow this process in order to do these. All right, so let's go ahead and do example 2, and I'll do that on the next video.